Sine of negative 150 degrees.
Festive Winter Holiday Light Edition.
Right, without a calculator. So let's draw ourselves a picture.
Always draw a picture.
Here's our quadrants and a negative 150 degrees. So 0 is here. Negative 90 would be here.
Going the other way. Going the other way this time.
Negative 180 would be here. So how far past 90 do we have to go to get to 150?
60 degrees.
60 degrees, which means we'll have 30 left over. So 60 degrees past negative 90. It is kind of helpful. Like normally I don't make a big deal about like drawing to scale because I feel like it, you know, stunts my creativity. But with 30, 60, 90 triangles, it is kind of helpful.
It's a little bit on the beneficial side to have those
bit.
Angles halfway close to what they're supposed to be.
Yeah, because then it's really easy to tell since we went 60 this way. Okay,
that's got to be 30, right?
Right here. And we went negative 150 to get there. So
hey, I think you connected that terminal side of the angle to the x-axis. Am I correct?
I did, and that's what we always do.
You didn't connect it to the y-axis.
No, we never want to connect to the
double
y.
check.
Always go up or down to the x-axis.
Right.
And so across from 30 degrees is 1, which, hey, that looks like the smaller side. It's negative 1 since it's going down.
Right.
The hypotenuse is 2. We've got negative square root of 3 over here. And
how did you know that was a 1 that went down like that?
Because it's a special right triangle, 30, 60, 90. 1 square root of 3, 2. The 1 is always across from 30 because our angles like match up and stuff. The smallest angle is across from the smallest side. Thanks. I don't know if that was a compliment to me or to math. I'm going to say you complimented both of us.
And we both
appreciate it.
Okay.
All right, sine is opposite over hypotenuse or y over r, depending on how you want to think of it.
Get comfortable with y over r, kids.
So negative 1/2 is sine of negative 150 without a calculator.
Wow, you're a genius.
Thanks. Okay, so let's
4
do
pi over 3.
4 pi over 3. Now we're getting into this like, I was going to use the line drawer thing and then I forgot.
Yeah, that's okay. Through. But that's a fairly straight line if you can ignore the squiggles.
Good. I thought it was pretty good.
Yep.
Okay, 0 degrees is over here. But I didn't mean to put degrees.
Not
we're
degrees.
Radians.
We're 0.
Okay, but it's not a big deal since they're both 0.
Right.
Pi is over there.
Yes, pi right there. There's a pi.
Pi halves.
Pi halves.
I mean, 1/2 pi is better to think of it.
And then 3 halves pi.
What you need to think of is it's 1 pi to get from here to here. And so if we're talking about thirds of pi, like we end up with being able to like break this up into thirds. You know, that kind of thing.
Right.
Which those aren't quite to scale. But like that's what we're talking about whenever we look at 4 thirds pi. We're trying to go more than 1 pi.
More than 1. How much past 1 pi are we going?
Well, I believe we're going 1
1/3 past pi?
Yes, because 4 thirds is 3 thirds plus 1/3.
That is amazing.
So we're going 1/3 past
pi. So we're 1/3 past pi.
And so that's going to be about right here.
That is excellent.
Okay, and the sooner that you can get the hang of like, it is helpful to think of what this is in degrees, like at least as far as the reference angle goes. If there's a 3 on the bottom, our reference angle is going to be 60 degrees because 3 times 60 is 180.
Shut the front door.
All about that conversion of pi and 180 and all that stuff. So
that's a genius trick.
This is 60 right here inside of our triangle.
Well, how can you tell if it's a 30-degree reference angle of what's on the bottom?
Well, if it has a 6 on the bottom, then it should be a 30-degree reference angle.
Why?
Because 6 times 30 is 180.
That is insane.
Yeah, or, really logical depending on, So this is a 30, 60, 90 triangle, so we've got our sides here just like up above.
Wow, exactly the same.
It's turned. Because
the hypotenuse, though, stays the same.
Yeah, the hypotenuse stays the same, but now we're talking about 60 degrees instead of 30.
30 degrees.
And tangent is opposite over adjacent, so that's negative square root of 3 over 1. I'm sorry, y over x is what I meant to say.
Y over x.
And that gives us, they're both negative. That gives us positive square root of 3.
Bingo, bango, bongo.
Okay. Secant of negative 5 pi over 4.
You had me at secant.
Secant. Why did I have you at secant?
Look at that word. How fun is that?
I like that as
it's
a word.
It's a fun word.
It's a neat word,
yeah,
I guess, as far as words go.
Yeah.
All right, so let's think about where negative 5 pi over 4 is.
Secant.
That sounds kind of negative when you say it like that. I prefer to see can. No, like I see that we can do this.
I see that too.
Okay, so negative 5/4.
Okay, now hold on. I'm going to try. Okay, let's see. 5 pi over 4. That's going to be 1 pi over 4 spot past 4 pi over 4.
Right, because negative or 5/4 is 1 and 1/4.
Yes.
Yes, and we're going in the negative direction, so we are going
upside down.
We're going 1, and then we're going a fourth of the way past it.
1/4 past the pi.
This is half, so this is a fourth right here in this quadrant, right here, over here, and it's. I mean that's
1/4. So 4 pi over 4 plus pi over 4 is 5 pi over 4.
You can't really tell, but that's a 45 degrees. So again, 4 times 45 is what gives us 180. So every time there's a 4 on the bottom, our reference angle is going to be 45
That's crazy.
degrees. Or really helpful. I mean, it's whatever. -1, +1, and the square root of 2. Remember the hypotenuse is always positive.
Right. Always.
We both agreed separately that that's the case.
I don't know why you would bring up stuff like that.
I don't know.
I was clearly right at one time.
Yeah. You were.
So the secant then of this is going to be the reciprocal of the cosine, which happens to be x over r.
So we want r over x.
R over x it is.
So square root of 2 over -1, which is negative square root of 2.
Blam! Look at that.
Perfect.
Trig functions, no calculators.
All right, later.
Hey there, kiddos. We're going to use the find the following if it exists rule here.
Okay, if
Festive Winter Holiday Light version.
Yeah, if the value is undefined, write undefined. That makes sense. That if it's undefined, we should write undefined.
I think if it's undefined, we should just write 0, right?
But that's not the same.
Yeah, I agree.
Zero is like an answer. Like if you have like 2 minus 2. You put it equals 0. You don't put it equals and then not write anything.
But what about 1 divided by 0? People write 0 all the time.
But that's wrong because you can't take 1 of something and divide it into 0 groups.
I agree.
So it's undefined.
So it has to be undefined, okay?
Okay, so
good talk.
These angles in this particular example are what we call quadrantal angles because they happen to line up with our quadrant lines, which like our x and our y axis.
These are going to be the ones you're going to love as we get going.
Because they're super easy if you understand what's going on. Where is negative 270 degrees?
Straight up.
Right, because if we count around, oh look, negative 270 is up here. Hey, isn't that the same as positive 90 degrees?
I would, yes.
Okay, so we can't draw a triangle if we're talking about an angle that's straight up and down here. But what we could think about is the fact, well, you know, our x, we went 0. We went 0 for x.
Oh, I'm coming apart.
Okay, we went 0 for x, but we could say that we went, I don't know, we could say we went like 10 for y.
10 indeed.
We could say that y here would be 10, and then if we think about what that makes r, if we do a little Pythagorean theorem action.
Halfway. Pythagorean theorem.
Halfway?
Yeah, because, I mean, there's...
Well, but...
You get one of them 0, so you only have like half of it.
Right. So the 0 goes, and it's just, oh, r would be 10.
Whoa, 10 divided by 10. I know what that is.
Okay, well, but we don't, we need to figure out what sine is. So we don't need 10 divided by 10. Sine is y over r. So, oh, no, you just said that. No, I'm sorry. I thought you were trying to do like a, I don't know.
It hurts when I'm right, Mrs. Stevenson, and that's okay.
I feel bad because
It's 2 days in a row that you've dissed me, but that's all right.
Okay. Sine of negative 270 is 1.
Going to be on YouTube later.
Yeah, well. Tangent of 3 pi.
3 pi. I know right where that is.
Really?
Yes.
How?
Well, because if I go to pi, then that's going to be over there on the left.
Right, on the left is pi.
And if I go all the way around the circle one time, that's 2 pi's.
Right.
My lights just went out. My festive winter holiday lights just went out.
And
so
then,
if I go one more pi past all of that.
Oh, hey, that's over here.
That would be 3 pi.
3 pi. So over here, we're talking about this angle that's along
the x-axis in the negative direction.
Right. So what we can do is we can say that our x here is, we went negative something.
Yes.
So
10.
Negative 10, sure, why not? And we went 0 for our y value, and that makes r be, would that be positive or negative 10?
Well, you know, r has to be positive, so.
Yeah, so it'd be positive 10. So tangent is y over x.
Mm-hmm.
Our y is 0. Our x is negative 10. Right?
I think so.
Right.
That's what we were saying all along.
0 divided into negative 10 groups, you would have 0. So
right.
That answer is 0.
Fabulous.
Yeah.
Tangent
fabulous.
is 0.
Fabulous.
I really like that net around your head, actually.
Thanks. I was going for like a nun cowl of lights.
It's festive winter holiday lights.
Yeah.
I like it.
Yeah. Okay.
It looks good on you.
Let's find.
I know right where 11 pi over 2 is.
Do you?
Yeah, I think so.
Okay. Do you think it's helpful here to actually change this to a mixed number?
You know, I think it's got some potential.
Yeah.
To do that, yeah.
Some potential?
Some potential.
Is that what you were going to do?
No, I was actually just going to count it off the first time and see if I got to the right spot.
Okay, what do you mean count it off?
Well, you start off and straight up you got pi over 2. And then you go all the way around to the bottom, and that's 3 pi over 2. So I added 2 on top. So if I add 2 on top again, that's 5.
Oh, I see what you're saying.
And if I add 2 again, that's 7. And if I add 2 again, that's 9. And if I add 2 more, that's 11. That's what I was going to do for the first time.
I see. I see.
Now, there are some other ways to do that. But
right.
for the first time, while we're
11 pi over
investigating,
2.
that's how I was going to,
So that's down
approach it.
here. So,
straight down.
So we've got for our x value, again, we've got 0. For our y value, we've got like negative 10 or whatever you want to use.
Right.
We just are picking negative. We're just
It could be
5,000.
whatever. Negative 200 million.
The whole point is that whatever value we have that's not 0, that's what r has to be, but positive if it's not already positive. That's the whole point there. So secant is r over x.
Well, the secant is the reciprocal of cosine, so yes, r over x.
So r is 10, x is 0.
Oh boy.
10 over 0. You can't divide by 0.
Just write 0 there, kids.
It's undefined.
Nope, you just write a 0.
Okay, and what?
Just write 0.
No.
Right? No what?
No, undefined.
No, but I don't.
Would you listen to me? It's undefined. If you divide, you cannot divide by 0.
Look, that is
Ever.
trig. That is trig mistake number 1 to write down that this is equal to 0. I'm telling you, and Mrs. Stevenson is telling you, don't do it. It is undefined. It is undefined.
Example 7: using one trig ratio to find the others.
Festive winter light holiday.
Addition. Yes. Find cosine theta and tangent theta using the given information to construct a reference triangle. So what we're going to do is not use our calculator because they gave us plenty of information for us not to have to. Calculators just make us round unnecessarily. Yeah. So we draw
approximate
a triangle.
Answers instead of exact ones. And by the way, this is where fun trig actually takes place.
Yeah. Yeah, I know. It's so fun. So fun. Where is sine positive 3 over 7? Remember that's y over r. So the y value is positive. R value is always positive. So we've got a situation like here in the first quadrant where we've got, what are you doing? Why do you keep messing with the lights?
My lights quit working.
We've got 3 for our y value, 7 for our r value. But that's not all.
If you act now, you can also get a positive 7 value and a positive 3 value in the second quadrant.
Right, over here. There's another place where we get that positive 3/7 ratio. Okay, because there's 2 places where our y value could be positive. And if you think back to all Smarty State calculus, all of the trig functions are positive in the first quadrant and sine is positive in the second quadrant. Every single time that we do this where we have a trig function equaling something, we can make 2 triangles. So they have to give us more information, which they did, in order for us to narrow down which one it is.
Yeah, now here's the deal. They told us that the tangent has to be negative. And there's actually
That's what this means. Less
two
than theta.
quadrants, less than 0.
Yeah. Oh,
yeah.
Oh, sorry. There's two places.
There are two places where that can happen.
Yeah.
So
it's tangent's positive in the first and the third quadrant.
And it's negative in second and fourth.
So
and
that
so
gets rid of these two quadrants as options. Sine
that leaves
wasn't
us,
down there.
Nope, it's all
it has
right.
to be
It's
that
gotta
triangle.
be. That's the process of elimination. We're going to use good old-fashioned Sherlock Holmes thinking.
Yeah, so we need to do some Pythagorean theorem real quick to get the third side. So 7 squared minus 3 squared, which is square root of 40.
I believe that is correct. Yes. So b squared equals 40. So b equals 40. It's root 40. Yeah.
Which we can simplify. That's 2 square roots of 10.
How do you do that so fast?
Because I think
Jeez.
40 is 4 times 10. Square root the 4 and get 2.
Do you teach math during the day?
Sometimes.
Man, you should really think about that.
2 square roots of 10. Now, is that a positive 2 square roots of 10 or a negative 2 square roots of 10?
Since we're going to go, we're looking for the x-coordinate in that left-hand direction there. And my kindergarten teacher, Mrs. Barnes, always said lefty was negative.
In kindergarten?
Yeah. Well, I was a super genius. So yes. No, not in kindergarten. Whenever I learned it in probably, 12th grade or something.
All right, negative 2 square roots of 10 is that third side.
Yep.
Now we can do what they asked us. And
Find the cosine and tangent. Yep. Now for these, we just go back to the whole cosine is the x-coordinate over r, which we just found the x-coordinate.
Yeah, negative 2 square roots of 10.
Over r, which is 7. So there's that bad boy. The other thing that we're looking for is the tangent of theta, which is going to be the y-coordinate over the x-coordinate. So
3
over negative 2 square roots of 10. And I'm pretty happy with that answer.
I'm happy with that answer.
But if you absolutely insisted on rationalizing it, you could get 3 square roots of 10 over 20 with a big old fat negative in the front.
Because we multiply the top and the bottom by the square root of 10.
Right.
So we end up doing 2 times 10 on the bottom and get 20, and we just put those
That's how it
together on
goes.
top. All right, so B, secant theta equals 3, where sine theta is greater than 0.
So again, we're going to use our cool Sherlock Holmes process of elimination.
Also, it's helpful to remember that 3 over 1.
Oh, yeah.
I mean, 3
yeah.
is 3 over 1.
Yes,
because
that is
we've
correct.
got r over, this is related to cosine, so r over x.
Right, r over x.
So our x value is
R! Okay.
Are you a pirate?
I am not
Okay.
a pirate. Maybe for today. R!
Okay, so x is positive this way,
Yes.
where we've got a positive 1 right there, and we've got a 3 right there.
And in fourth quadrant.
And in the fourth quadrant. They actually share that side there. It's kind of
Shut the front door. Look at that. They
neat.
share the side.
Yeah. So we have to figure out which one of those we're talking about. Sine has to be positive, and sine is positive
Only in the first
and
quadrant.
second quadrant,
Yeah.
but they overlap in the first. So that's the one we want, is the one that's in the first quadrant. So we need to find the third side. Now, some of you may be inclined to put square root of 2 here.
Don't do that. That's a lie, vicious lie.
We need to find, using the Pythagorean theorem, we need to find it.
Yeah, and if you'll notice right here, if you'll just take the whole 25 seconds it takes you to run through Pythagorean's theorem, you're going to see there's no square root of 2 in this one.
Yeah, 3 squared minus 1 squared is 9 minus 1.
That's 9 minus, it's 8.
So square root of 8, which is
2 square roots of 2.
2 square roots of 2.
But not just the square root of 2. Okay?
No.
So 2 square roots of 2, there you go. Bingo,
Okay,
bingo,
1,
bongo.
2 squared root of 2, 3. So cosine is x over r. Oh,
And
which we actually didn't need the triangle for.
Yeah,
We
that's
could've just
1/3.
flipped-
That's right
we
off
could've
the bat.
flipped secant.
That's okay.
Anyway, we needed it for tangent.
Yes, and the tangent in this case is going to be the y-coordinate over the x-coordinate.
So that's 2 square roots of 2 over 1, which is 2 square roots of 2.
There you go.
Cotangent theta is undefined, and secant theta is negative.
So when I hear that something is undefined,
What
I
does
feel
that
like
mean?
there should be a 0 someplace.
0 on the denominator?
Yes!
So-
yes.
so we're
0 on the
saying-
denominator.
That what is the ratio for cotangent? X over y?
Yes.
So our x has to have some value, and our y is 0. And we need to draw that picture. This will be a quadrantal angle. That's the only place we end up with undefined.
Right.
Right?
And we're going to be undefined when we are along the x-axis in this case, because y would be 0.
So y is, oh, okay, I see what you're saying. So either we're going this direction.
Yes.
Or we're going this direction.
Yes. I agree to both of those.
Okay, so secant theta is negative.
Now secant is 1 over cosine.
Right. And so that's talking about our x value would have to be negative. So that means we're looking at this direction, the one on this side.
Which would be?
Well, we could start trying to think of this as like a point -1, 0.
Right.
Okay, where that's our x and our y value, and then our r value would be the length of this line, which since we went out 1, our r value is 1.
Yeah.
So then cosine is
-1.
-1 because it's x over r, and tangent
would be 0 because that's going to be the reciprocal of the cotangent.
Right, because if it's undefined, we have a number over 0, and so now if we flip it, it's 0 over a number. Which,
right.
Yeah, 0. Yeah,
Game
totally.
over.
You know.
Okay.
Oh, periodicity.
Periodicness.
Periodic functions. Hey, it turns out that these trig functions are periodic.
I like that word, periodic, because it means it just keeps happening
over and over
on
again.
a schedule, over and over
like,
and over and over and over and over.
Like when we keep drawing this whole 0, pi, 2 pi, blah blah blah.
3 pi, 3 pi.
Like the
4
fact
pi,
that
4 pi.
4 pi, okay, and we
5 pi?
we could keep going, but we're not going
5
to.
pi?
We could.
Okay, all right.
Okay, so what happens is that sine of 0 is the same as sine of 2 pi, which is the same as sine of 4 pi, right?
Yes.
Right?
Yeah.
Like whatever.
They give you the exact same answer every time.
This direction. And so sine and cosine both have a period of 2 pi, and we'll really dive into that next section. Then tangent actually is weirder because it actually has a period of pi over 2, and we'll look at why that is.
Period of pi.
Oh, yeah, it's half of the...
It's half of the big dog. That's okay.
Okay.
Mistake number 2, all on the same day, but we won't talk about it.
So tangent of 0... Tangent of 0 is tangent of pi, which is tangent of 2 pi.
Which is tangent of 3 pi.
And if you look at, like a unit circle, which you may or may not have heard of before.
The unit circle, I love the unit circle.
If you look at what it is at 0 and then pi and then 2 pi, if you keep going around, those are the same values. Because of the fact that because tangent has the first and third quadrant that have the same signs.
Right.
Yeah.
They start to repeat a little quicker.
Yeah. So let's use this idea of periodicity to find each of the following numbers without a calculator.
Whoa, look at that. 57,801 pi over 2.
That's a lot of pies.
Whoa.
Over 2. What if...
I mean,
What if we made this into a mixed number real quick?
Knock your socks off. Just go right ahead.
All right, so 2 with the 1 left over, 8 with the 1 left over, 9, nothing left over, 0, 1 left over. 28,900 pies plus a half pi.
I know right where that is.
I do too.
Pi over 2.
Because
that's an even pi right there.
Even
an
pi.
Even pi is over there.
Oh, yeah, all of our even pies are on the same side. All of our odd pies are on this side.
It's like they're periodic.
Even pies, and then you add a pi over 2 to that, so that means we're up here at pi over 2.
Right.
So let's think of this like the point, I don't know, 0, 1.
That is a brilliant point to choose. What made you pick that one?
Because it's so easy to use 1.
For a radius.
Yeah. So 0, 1
what is going on around here?
With a length of 1, which means that sine, which is y over r, is 1.
So, let's do another one.
Now,
can we do another?
Yeah, let's do another. We have cosine of 288.45 pi minus cosine of 0.45 pi. Okay, so here's I think what's important. Like, how far apart are these two angles?
Okay, hold on. Don't tell me. 8.
Okay, so what we could do is we could rewrite this first angle as 280.45 pi, that's the second angle, plus 8 more pi's. Okay? And the reason that this is important is because if we're talking about them being 8 pi apart, these are the same values.
Get out of town.
Because 8 pi divided by 2 pi, that divides evenly. So that means that basically whatever this first angle is, we're going around the circle 4 times, and then we're back at the same spot.
I feel like this is like there's been a light that's turned on.
Yeah, just one or a lot?
Maybe more than one.
Okay, so this would give us
Maybe
some value.
Maybe they're winter holiday lights.
But we would get the same value. If we're getting the same value both times and we're subtracting, this would be 0.
You're mind blown.
Yeah, I thought so.
Wow.
I thought that would happen.
That's just crazy.
C, tangent of pi over 4 minus 99,909.
I know. I think I know right where that one is.
Okay.
I think it's going to be over. It's going to be like just the exact same thing as saying pi over 4 minus pi.
Okay, because all our even pi's are on the right
side. So all the odd pi's have to be lefties.
Left. So, and it doesn't matter that it's negative really if we're just talking about pi, because we have negative. We can make all these negatives and that still works.
It's not a problem.
So you're saying now which way should we go for pi over 4? Like the positive direction, right?
I mean it says positive pi over 4 there, so yes.
So yeah.
So start from there, go there. Yes,
right.
That's exactly what I would do right there.
Here.
Yes.
So that's a 45, 45, 90 triangle, and gives us -1, -1,
which is 1.
2. So tangent is 1.
Jeez.
That's how you use periodicity to find trig functions.
Periodicity?
Incidentally, if you were to type these into the calculator, you may not get those answers. Even though 1, 0, and 1, those are like normal answers. It's not like, oh, I got this weird fraction. Like, if you try to, at least on A and C, if you try to type those in, your calculator may not actually give you the correct answer.
I don't believe it.
Well, try it yourself. I'm just saying what the book told me. The book said, hey, try it and see. You might not get the right answer. And that has to do with the fact that we're using such big numbers, I think.
And it has a rounding error.
And there is a rounding error, perhaps.
That is very interesting.
Do you know how... never mind. Let's not. Never mind.
Okay, good talk.
Yeah.